I'm Jon Wiley, and I work at Google. I've been at Google for about 9 years. This is a talk about what keeps me up at night. This is all the cards that have everything that keeps me up at night on the cards. I'm Director of Immersive Design, which is actually a title I came up with this week because I was trying to figure out what to call myself. I work on virtual reality at Google, but I'm also going to be working on augmented reality at Google, some of the stuff I'm working on right now, and sort of volumetric design and three-dimensional computing and fun stuff. So I wasn't quite sure what to call myself. I think it's called immersive computing, immersive design. It's a new frontier, and so we've got to figure out kind of what all these names are. So this is going to be about what keeps me up at night. Good and bad. So I think this phrase is often used as sort of a negative connotation. It's like, what keeps you up at night? It's like, oh, that's like worrisome. But there's things that keep me up at night, too, that are exciting and are interesting, and I get really excited about and want to write down a bunch of stuff about. And so I'm going to talk a little bit about that, too. So a bit of history. As I mentioned, I've been at Google for a little while, and last year I went to Google I/O. So Google I/O is Google's kind of annual, it's mostly a developer conference, but it also tends to be some place where we occasionally make product announcements. And last year, Google I/O 2014 was actually the first time that I attended I/O. Usually I just watch it from my desk. And the reason I was at Google I/O was because I was there to present material design. It's kind of hard to believe, actually, that that was last year that we presented that. So much has happened in that time. But I was actually part of the material design team. I'd been working on that for 2 years prior to presenting it last year at I/O. And also at I/O, at the same event, we announced Google Cardboard. So hopefully most of you have had a chance during the breaks or whatever to just kind of go back there in the back. We have a kind of a Google Cardboard set up. Hopefully you've picked up your Google Cardboard. This is it right here. This is Google Cardboard. And in 2014, last year, I heard about this at the same time everybody else did when we announced it on stage. And so I was kind of like, what is that? And we announced it with no fanfare, right? It was like, hey, everybody gets one of these. Peace out, right? And so everybody was kind of like puzzled about what it was. This is it. This is actually V2 of Cardboard. And if you haven't gotten yours yet, it's pretty simple. This is the sleeve. Just take the sleeve out. And you just fold it like this and put it around. And it's got these lenses in it. And do that. And then you're ready to go with a phone. So you pair Cardboard with a smartphone. Can work on iOS devices or Android devices, and you run software on it that projects 2 points of view into both of these lenses, and that gives you stereo. But not only stereo, so it's like the old ViewMaster, right? You know, the ViewMaster, you like, and you get to see like all the pictures in stereo, Chichen Itza, or all these the pyramids in Egypt or whatever. But one of the cool things about smartphone technology is that they have sensors in them that allow you to detect orientation of the phone. And so now, with something like this, very, very simple technology, you can actually just look around and you're immersed inside of this world. And so as you turn your head and as you look and you see things, you can see these things in 3D and stereo. Near things are near, far things are far. And when I tried it, the first time I tried it, I said, this is one of the most googly things we've made in a long time. And the reason I said that was because it's really simple technology, right? It's really, it's like you could barely call this technology. It's a little bit of optics, a little bit of cardboard, some plastic. And that simplicity sits on top of something that's very powerful, which is the phone. And this is actually pretty similar to how, if we think about sort of the iconic Google experience, the Google search page, Google Search. So I worked on Google Search for 5 years prior to working on virtual reality. And that is a great example of very simple, intuitive technology. In fact, when Google, the first Google homepage came into existence, it was competing with a bunch of things that were really noisy. And the Google homepage was actually really simple. It's just a white page with a box and some buttons. But it sat on top of some incredible computer science, some amazing technology. In fact, Google Search was probably one of the first cloud applications that you could open up something in your browser, and that was actually being powered by these massive data centers, right? And so all of that technology, sort of finding an endpoint into something like this, it was really fascinating to me. And what's also cool about cardboard is that it, just given the materials, it sets expectations way down here, right? You're just like, what? But the experience of cardboard and the experience of virtual reality and being immersed that way, that experience is much better than the expectations. And in that gap is delight and something very interesting. And this kept me up at night. I was at I/O 2014. I was looking at cardboard. I was playing with it, and I kept thinking about it. I kept coming up with all these ideas about like what I would do in VR and all these kind of products that would be really awesome to make. I kept turning it over in my head. And when you do that, when you're staying up a lot and you're writing down these ideas and the ideas don't stop, that's something you want to pay attention to. So I made a decision last year to leave my comfortable post working on design for search. I'd spent many years. I knew the area inside and out, and I sort of upended my career and said, I'm going to go work on VR. Woohoo! Yay! And I joined their VR efforts full time. So virtual reality, it's gone through a lot of cycles. I think if you've paid attention to virtual reality technology going back to the 80s and the 90s, it's gone through lots of these, what we call, the hype cycle, right? It's the this peak where it goes through this like, oh my gosh, it's gonna be amazing, and then sort of, the trough of disappointment and disillusionment and whatnot. And VR has actually gone through several of these. And part of the problem is that the idea of virtual reality is powerful, and it's been possible to create virtual experiences with really expensive technology, like military technology or university technology. I'm a graduate of the University of Texas, and we used to hang out with like all these like weird roboticists and people, and they'd strap like a big CRT on your head from the ceiling, and they'd try all this stuff. It was really expensive, not very accessible. Mobile technology, though, has made it possible to take all of the things that you need for VR, which is good tracking, and good sensors, good displays, good CPU, so that you can do all the processing necessary to render this to render it in real time. Mobile technology has been a driver of this, and all these things have come to a head at this point. And so now I think VR is probably here to stay. I'm gonna proceed on that assumption. And in the next year to 18 months, you're going to see a lot of VR devices becoming available to consumers. The most popular of which is Oculus. I'm sure all of you have. How many of you actually tried Oculus Rift? All right, my people, VR people in the house, fantastic. And how about the HTC Valve, the Vive headset? Got a couple of people, right? Vive, the Vive will be out next year. Oculus will be out next year. Sony Morpheus will probably be out next year. And these are all very high-end devices, VR devices. And I'll talk a little bit about what that means in a bit. But over the course of the next couple of years, you're going to see a lot of, it's like anything that is new. It's this new technology. It'd be like the internet in the 90s. There's just going to be a ton of press about it. It's like, oh my gosh, VR is the most amazing thing ever. And then there's going to be people enthralled by it. They're going to be talking about, what's your VR strategy? Are you VR first? There's just going to be a lot of hype in it, and there'll be a lot of noise, and we'll have to sift through the noise to find the signal. I think there's going to be a lot of cynical reporting, right? It's a doomed fad. No one's going to use this. Why would you strap a computer to your face, right? And somewhere in between lies the truth, right? On the one end, it's very promising, interesting technology that probably will, we think, have value. On the other side of it, there's definitely some complexities involved, and there's definitely some user experience involved in terms of the cost of getting into a VR experience. So as I said, when I first saw cardboard and when I was able to try lots of these VR devices and I started thinking about VR and it was keeping me up, I was mostly thinking about the product experiences. So I was really excited about sort of the product potential of VR. As a designer, I hadn't given a lot of thought. I was excited about spending time in VR as a consumer and being able to I'm an astronomy geek, so having a virtual planetarium that I can step into and point at the stars and do fun stuff. I was really excited about the product ideas. In terms of thinking about the design, I didn't give it a lot of thought, and in order for me to actually make VR a career choice. As an interaction designer, to actually turn that into a career, to make a choice to go in that direction, I think VR has to be interesting and exciting from the perspective of an interaction designer. So thinking about design, if you set out to be a designer, perhaps you go to school for it, you might get a degree in HCI, human-computer interaction. And I think a lot of what we do as designers in that field is like humans on one side, computers on the other, and there's a chasm, and we're trying to bridge that chasm. And sometimes, if we're lucky, the computer is the one that moves across the chasm towards us humans. Our humans are adaptable, and that's great, but we're not that adaptable. We're kind of stuck in our ways. We still have big hands and whatnot. So you start with computers, and the language of computers is like punch cards and things like that. And that's really the human learning the computer language, right? It's like, okay, I punch these cards or do something. Eventually, we moved on to like switches and dials and lights and things like that. And that was still mostly the human trying to understand the computer. We got the command line interface. That one's actually a little bit of the human and the computer coming over, right? So now it's the computer starting to understand. You don't have to program an assembly. The computer actually is starting to have some language, uses letters, right? We get a keyboard out of it. That's pretty exciting. And in each of these advances, you get more people using computers. There was a quote earlier, actually. I think I saw Jenna tweeted it, that was said at the conference earlier today. You can either improve the users or you can improve the technology. But the benefit you get typically out of user experiences when you improve the technology. Humans have certain expectations about how the world works. They have certain evolution, right, in terms of how they approach things. And you want the computer to fulfill that, not the other way around. So and then we had the graphical user interface, and then you have a ton more people using computers at that point. And then with smartphones and touchscreens, that's even the computer getting even closer, right, to the human, because now I can directly interact with software. I can directly manipulate software with my hands. So I've got millions of years of evolution of like manipulating objects and picking them up and doing things with them. Excuse me. And now we're getting to the point you can actually touch software. And so this is a new moment. Suddenly you get an explosion of usage of computers. Now, it's not all due to the fact that it's touchscreens, right? It's miniaturization, it's very small. But if you shipped the world a bunch of smartphones and then you just included a keyboard with it, right, it'd get less usage. But humans have these physical expectations, right? They come to it with their bodies and how they work. And actually, this is a lot of the foundation behind the thinking in material design. Material design is about sort of coming to the table with the recognition of the capabilities that the human has and the assumptions that the human has, right? When we interact with physical objects, we expect them to have mass and momentum, and they have friction and physics. And so when you're trying to create an authentic software interface, then the complexity of that goes way up, right? Suddenly, it's not just like the one web designer, just making like content pages. Suddenly, you have like motion graphics, and you have to make it performant. You have to take care of the frames because reality doesn't drop frames. And you have to take care of the latency. It's this fluidity, this continuity of state, right? It's not one state, A and B. It's about going from one place to the next, but it's that continuity of states, right? So playing into the expectations that humans have about how things work, particularly when they're physically interacting with them, was a huge part of material design. So VR, virtual reality, is another one of these transitions. It's another one of these moments in which computers are getting closer to the humans in terms of how humans interact and perceive the world. But it's turned up to 11. Because with phones, I'm still designing for a square. It's not all that different, in many ways from the design that came before it. I'm physically interacting with it, but I'm mostly just using my hands. And it's generally in a single dimension, right? Or it's 2D still. Whereas if you think about virtual reality, it becomes volumetric. Like depth becomes into play, but it's not only that, it's about the turning of my head. So I actually now have head motion, and I have body motion. Everything. The first time most people get into VR, a lot of times they do this. Where's my hands, right? So they're starting to have the expectation, again, the physical expectations that they have in the real world. They're bringing them they're bringing that into virtual reality. And if virtual reality fails to meet or exceed those expectations, people have a bad time. So this is actually what drove me to start working on virtual reality, is because I saw that there's a lot of potential here for the computer to get closer to the human, and therefore the human's going to get much more powerful in the use of computers. I didn't really know anything about VR when I joined. I mean, I'd used it, but I didn't really know about it as a designer. I actually assumed that the transition, in terms of my career as a designer, I assumed the transition to VR would be similar in complexity to my transition to mobile design. But having worked on it for about a year now, it's going to be more complex, and it's going to be more complicated than mobile. So what makes it complicated? Well, it's sufficiently complex and different from existing design that the folks have devoted many hours to it. Earlier today, I tweeted a link to a bunch of other links, a page that just has long link of resources for designing in VR. There's lots of videos, lots of people thinking about it. Clearly, by no means solved, because we barely have any consumers using VR at this point. But people starting to think about it and work on it right now. One of the things that we created at Google was the Cardboard Design Lab, which you can download from the Play Store if you have an Android device and put onto your Cardboard device. And what it does, it just gives you kind of like we thought, what better way to talk about VR design than actually putting it into virtual reality? It's part of the reason I don't have any slides today, is because it's all 2D stuff, and it just doesn't convey the real dimensionality of anything. I think for us to actually have coherent presentations about VR, we're all going to have VR. We're all going to have to be step into a virtual reality in order to understand it. So what makes it complex? Well, I'm going to throw out a few things real quick. And this is all stuff that I just got bombarded with when I started designing virtual reality. So one, and there's going to be a lot of jargon here, right? So every discipline has its jargon. So 3 DOF versus 6 DOF. 3 degrees of freedom versus 6 degrees of freedom. So Cardboard, based on the sensors in your phone, is a 3 DOF device. It's 3 degrees of freedom. So it's basically like on a tripod. It's like a pivot. So you can rotate around the axes. Rotate around the X, the Y, or the Z. 6 DOF is rotation plus translation. So you can move in those axes, and that gives you the 6 degrees of freedom. And to something like the Valve HTC Vive headset, they have what they call room scale VR, where you can actually be in a virtual environment and walk around in a full-size room. Another issue is proprioception. This is a word I did not know before joining virtual reality. Proprioception is your body's ability to sort of understand where the different parts of your body are. It's what enables you to close your eyes, and if you're sober, do that, and touch your nose. You know where your hand is, you know where your nose is. This comes into play into virtual reality because you could set up weird conflicts between what's real and what isn't. Again, this is a thing where it's like, oh, I've got hands, I feel my hands, but suddenly my hand is passing through a solid object, or it seems solid, but it's not there. And so you get these kind of weird conflicts between what you feel like ought to be there and what isn't. There's another big issue, big challenge with the technology side of virtual reality, and that's vergence accommodation conflict. So I'll show you what that is. It has to do with depth perception and focus of your eyes. If you get into virtual reality design, you end up learning a lot about optics and how the eyes work. So one quick way to do this is if you close one eye and you hold your thumb up like this, and you do like the camera 1, camera 2 thing, right? You'll see your thumb pop back and forth, and that is basically how your body and how your brain determines depth. That's the stereo images coming into your eyes. It's just like changing of the background. But one of the things that happens in reality is that the actual distance to the object, the vergence, right? So your eyes are like focusing in, so that angle as they turn into each other to focus on that object, that the vergence distance where they converge, that distance is equivalent to the focal distance. So what's happening is your eyes converge, and it says, that's how that far away that thing is, based on that angle. But then your body also focuses your eyes by changing the shape of your eyes. And that distance is the same. But in VR, something can appear far away, but is actually being rendered much closer to you, because the actual screen that it's rendering on is right in front of your face. And so your eyes have to focus on something that's much closer than what it actually appears to be. And this can lead to eye fatigue. And with VR devices, what you get, and I'm hoping more VR devices start publishing this data, with VR devices you get actually what's called a virtual screen. So it's because of the optics, not everything is here. It's actually being projected at what's a virtual screen, which is probably, depends on the device, it's on the order of like 1.5, 2 meters. And that's kind of like the safety zone. So if you put things in that space, it's less fatiguing because there's no conflict. Your eyes are focusing at the same spot that they're converging. And probably a big one, and so the reason I was putting this up here is because if it's like the virtual screen distance is here, so that's a good spot. But if I'm over here, the virtual screen distance is much closer. So the other part of this, too, is what's called sim sickness. And sim sickness is what happens. It's basically like, it's motion sickness. It's the same thing you might get if you're in a car and you're reading a book or you're on a boat. You get seasick. And it has to do with the vestibular system in humans, the part that tells us how we're moving versus what we see. And a challenge in VR is that you don't feel acceleration. You're not actually moving. And so if you move somebody in VR, or you move objects in VR that are very large, you can actually make people ill. The stakes are pretty high for design. If you do something wrong, you can actually make your users physically sick. And so I'm probably one of the worst people to be working on VR, frankly, because I don't get motion sickness, which is a blessing in many ways. But if you're actually working on things that you hope don't make people sick, I basically end up saying, here, try this, which can get a little bit a problem. And one of the things that can also cause sim sickness is frame dropping. So performance turns into a really big deal for VR. If you're looking around in a virtual world and tracking stops, even for a moment, then it's basically like, imagine walking around the street and the entire planet just goes boom, like that, right? If it does that, your body just goes boom. It doesn't know what to do. We actually had somebody who was working on one of our applications in a VR environment. He was walking around, and there was a bug in the system. And what the bug did was that it instantaneously turned his entire environment 180 degrees. So the floor became the ceiling. And it did that instantaneously. And his body didn't know how to respond. It actually just went into a panic mode. He fell down to the floor immediately, just instantly. He was fine. But it's like, this is where a bug can actually cause some real issues. And so we have to be very careful, and we have to be very cognizant of what we're doing in terms of the design of these applications. Input is another issue. We haven't really solved the input problem in VR yet. As I mentioned, everybody wants to do this. They all have their hands, and that's natural. We're humans. That's how we interact with the actual environment, typically. We have our hands. Turns out hand tracking by computers is really hard. It's getting there. It'll happen eventually, but it's really hard. It's a little bit like voice recognition in computers. So, voice recognition for many, many, many years was just bad. And even if you get to something where you have an input mechanism, whether it's voice or hands, talk about voice. If it gets to the 90% accuracy, right, that's failing 10% of the time. And the thing about humans, right, is that we remember all of the failures. We don't remember the successes. So if you have an input mechanism that fails 10% of the time, you're just gonna give up on it, and you're gonna try to use the thing that works 100% of the time, which is why voice search is difficult because typing's easier. Voice search has gotten much better now, by the way, and that'll happen with hands too. But right now, what we're stuck with, for the most part, is what the industry seems to be converging on is controllers. So you get these tracked controllers. So the Vive has them, Oculus will have them, Sony Morpheus has the PS4 controllers. And that's another, the human is really coming across the bridge, not the computer. It's kind of a crutch. You have to hold these things. Not entirely. It is useful to actually have haptic feedback, because another issue with virtual reality is if you press on things, they don't exist, and that feels odd. So having a button you can actually press is helpful. Other issues with thinking about designing in VR is seated versus standing. I think VR is going to sell a whole lot of swivel chairs. It just, it's like, it does this, and then I can see this, 360. But probably the biggest challenge I've run into as a designer is that it doesn't look like what I think it's going to look like. So years and years of intuition and experience of working with 2D things, even if you were a 3D designer, what you see when you're designing over the last many years is that you see everything as 2D. And so you think, oh, well, I can make something, I mock it up, it looks beautiful, and I'll just pop that over here into VR. And it looks horrible, and it doesn't work at all. And our intuitions about what looks good represented in 3 dimensions just don't match with reality. And that's actually something that you really, as far as I can tell, you can only learn through practice. If your design discipline is to actually translate ideas into 3-dimensional objects, if you're working in, if you're an artist or you're working in sculpting or perhaps architecture, you might have this skill already. But for me, it's been difficult. And I'm having to dig up some old knowledge. So I did not set out to become a designer. So I didn't study design. I didn't study human-computer interaction. I actually have a theater degree. I have a degree in acting. And so for a long time, that was just a piece of paper on the wall. Good job, John. Yeah, he went to college. But now, as a designer working in immersive technologies in VR and AR, I'm having to dig up my theater history, my study of staging and lighting. Theater is actually a really interesting medium for VR and thinking about VR because unlike, say, film or television in terms of the narrative, in film and television, the narrative is controlled by the director. They get to control the shot. They control the framing. They control where the camera goes. They control the editing. In theater, there's no control over the camera. Y'all each have your individual control over your own camera. You get to look wherever you want. And there's a certain amount you can do in terms of staging it and crafting it and putting the scene in, but maybe you have a theater in the round, maybe you have a proscenium, et cetera. But there's lots of things that go into actual theatrical design that I'm finding to be very useful in VR design. Set design, lighting, as I mentioned. Architecture is clearly, you're building virtual environments, and architecture is about building things that function for humans. And now you're having to build virtual environments that function for humans. Ergonomics, as I mentioned, knowing like how far humans can turn their torsos, how far they can turn their necks. Being able to turn your neck this way is different than if you're holding cardboard, right? Your arm's up, and so you're actually restrained a little bit. So if you're actually designing an interface that you expect to fit within a certain field of view or a certain radius, you actually have to take into account how flexible humans are. And whether or not they look up like this, or they look up like this, as you turn your head this way, you're really increasing the amount of pressure on your neck muscles, the amount of weight that's actually hitting you as you're looking down. So we have to be really careful about where we put things in VR so that we're not stressing our humans. And as I was thinking about theater and kind of going back to my studies in theater history, I remembered a word which I will probably slaughter because it's German. Gesamtkunstwerk. Did I say that right? Does anybody know? Yeah. Gesamtkunstwerk, which is a work of art that makes use of many art forms and strives to do so. This was actually popularized by Richard Wagner as part of his theory about drama and the opera. And the idea is you're taking lots of different art forms, lots of different things, and composing an experience together in harmony with each other. And I think about that a bit when designing for VR. So it's complex and complicated, and there aren't any good tools yet. If you want to get into VR design, you want to prototype quickly in VR design, your best bet is to learn Unity. A lot of the skills today for VR exist, and a lot of the tool sets come out of real-time 3D game design. So Unreal, Unity, game engines, et cetera. But there's no tool yet for creating VR experiences. I think those tools will come, but presently it's pretty difficult. The other thing, too, is it's going to, I think, it's going to require more specialization in roles. So I think we saw a pretty big transition from desktop web design days into mobile software application design. We had a fair amount of specialization in roles. You started getting, at Google, we started hiring motion designers, right? More visual designers, typographers, because the displays got better. And prototypers, engineers who can really squeeze out that every last bit of frame and performance. And all of this is a consequence of sort of the complexity of delivering a high-quality program, high-quality experience on mobile. Well, I think the same is going to happen in VR, except you're going to end up with more specialization. You're going to have 3D generalists. You're going to get modelers. You're going to get light people. It's like the theater. You're going to have people who focus on audio design, sound design, environment design, lighting design, right? And they're all going to come together to try to create these experiences for people in VR. If you intend to be working as a designer over the next 10 or 20 years, I think this level of complexity is headed your way. And I think that design for virtual environments and designing for augmented reality environments and the Internet of Things and whatnot. I think that's all gonna land in your lap if you're working in design. Think a bit about cardboard, right? Cardboard is just this, natural endpoint to a lot of the trends that we see in terms of miniaturization of compute and access to bandwidth, the distribution of these things, right? It's just going to be more and more of it. And as I said, it's largely driven by mobile. Right now, 2 to 3 billion people on the planet have access to a networked supercomputer in their pocket. And by 2020, that number is going to be about 6 billion people. So on the order of, most of humanity will have access to a networked supercomputer, smartphone technology. Concurrent with that will be an explosion of other lesser devices that still have computer and wireless radios in them. We're starting to see things now, we call it the Internet of Things, home automation systems, but there's also, my friend Scott Jensen works on a project called the Physical Web, and it's about just embedding almost anything with just enough compute to broadcast a web address. That just connects you to some service in the cloud, right? And then suddenly anything can have a website, but if it has a website, it can have an app, it can have an interface, it can have a bunch of other stuff. Always networked, always updating. Endpoints for VR, if we get to a point where we completely solve all technological problems with virtual reality, you get to replace reality. That's what you get. It's teleportation. If you're capturing reality, and so we're working very hard on capture technologies, that's one of the things you could see over in the cardboard booth area is the jump camera, and that is the ability to capture 360, fully immersed stereo video, and it's one of the best of its kind in the world. You think about 10 or 20 years in the future, you'll basically be able to fully capture an environment like this, completely, totally, in 2020 resolution, potentially in real time, and rebroadcast that back to someone else, right? If it's recorded, that means we built a time machine. Because you can just go through any captured environment, right, and just replay it back in time. We can also, with virtual reality, create entirely imagined realities. So we can bring people, if you want to go study at Hogwarts, that's fine. We'll just make a Hogwarts for you, and you can go do that. Augmented reality is very similar. Anything that can have an interface will. You can just broadcast an interface to everything. You won't need phones anymore, or at least you won't need all the black mirrors. You won't need the phone. You won't need the tablet. You won't need the display. You won't need this, right? I mean, again, this is about fully realized augmented reality. It's wide distribution. And I don't claim that AR and VR tech is going to accelerate in the same way that mobile phones do. I think mobile phones occupy a special niche. But in augmented reality, there's no need for sort of these physical manifestations of displays and interfaces. But that's all just raw technology, right? That's just pure potential. And those of us, we've worked in technology for a long time. We know that technology can be very positive. We know it can be negative. We know all this complexity can have unintended side effects. So often, like vision videos, will paint a picture of the optimistic side of potential. So if everybody has a supercomputer and we have total virtual reality, we have total augmented reality, then we're going to get all this amazing stuff. It's going to be great. It's going to be this positive future of jetpacks. And if we do nothing about technology, if we don't design it, right? No design is still bad design. Then we get all, just sheer entropy means that all of the complexity of the technology that we're generating and giving to humans is going to generate these horrible unintended side effects. You don't need you don't need malice or abuse, right, to create bad effects of technology. Simply complexity and error will take care of it. So why does this matter? Why does this matter for design? So I think mostly design is reactive to technology. Not entirely, but I think a lot of design is reacting to technology. I think we're creating solutions within the constraints of the technological system that we inhabit. Or we develop opportunities as they manifest. But I think the discipline of design needs to get better about getting ahead of the power and the complexity and the entropy that lies in our future, because I actually think it's arriving pretty fast. And I don't think that we're going to have time to be reactive. I think we're going to have to be proactive if we want to create a positive future. And I think we need to anticipate these trends in technology, and we need to understand their potential and the pitfall, and we need to design a future that magnifies the potential while heading off all the negative outcomes, or at least minimizing them. I think product design, designing of products within that context is actually insufficient. I think we need to design systems and platforms and tools, invest in meta design, investing in our own tools as designers, as a design community, our own approaches, getting those better. This conference is a good start. And understanding, the order of things, right? Understanding in order to create solutions which withstand the onslaught of the complexity that our own technology is creating. So the way we do that is listening carefully, which designers are generally good at, paying attention to developments in the fields at the edge of technology. Be looking at those things that maybe aren't in your area of expertise, that might be on the very edge of tech. Getting outside of your domain. Get close to this new technology. Try it out. Very pleased to see that there's a lot of hands for people who've tried virtual reality, even though it doesn't really exist as a consumer technology yet. Try out home automation, even if it's kind of broken and clunky. I think consumer technology also has a bit of a glitzy component, and so don't forget enterprise tech. Don't forget accessibility technology. In many ways, a lot of technology developments that are on the forefront, that are on the bleeding edge, are to assist people who have disabilities. If you think about, right now, it's possible for people to be fitted with bionic arms that read brain waves and allow them to actually to manipulate their bionic arms. Almost like telepathy, right? And if you think about that technology and the ability, it's like, oh, their interfaces, they think about it. What might else we apply that capability to? But those kinds of techs, enterprise and accessibility tech, is often ahead of the curve, so it's very useful to pay attention to those. If you can, I do suggest trying to devote some or all of your energy to working on platforms, to working on systems of design, to working on tools of design. This is one of the reasons that I worked on material design. What drew me to it was because it was an enabler for a positive outcome, hopefully, to create more good design in the world. Anything that can help us make sense of the complexity in which we work, right? Anything that can help us as designers manage our own complexity so that we're creating better software or better tools for others. And we need to, tools that provide enough abstraction so that we can create, positive solutions and minimize unintended consequences. And I think the best outcome is that we tell a story about the kind of world that we want to live in, and that the story that we tell is believable. And it's detailed enough that collectively, the engineers of the world and the product managers of the world and designers of the world, the builders, everybody together can work together to create that future. So we have to be thoughtful about it, and it has to be true to what technology can do, but also aspirational of that technology. We have the ability to shape where the tech goes. We have an ability now, today, to tell a story that would direct these foundational technologies into a good place and not to a place that might cause problems. If we've anticipated and we've acted ahead of the onslaught of complexity, if we've prepared carefully for it, then by building these tools and working on these systems, the network effects of this will be amplified and will create positive outcomes and positive systems, and the world will be much better for it. So get ready and work on those things and make it better. Thanks.